Welcome to the HYPOTHEkit YouTube channel. My name is Scientist Erica, and this is our guest scientist,
William.
Today we will be learning about acids and bases with an experiment that you can do at home. You're probably saying to yourself, what are acids and bases? Great question. Our world is made up of many different atoms. The two important ones that we'll be talking about are positive hydrogen ions, written as H+, and negative hydroxyl ions, written as OH-. Now, in order to tell someone how acidic or how basic something is, we use something called a pH. This scale goes from 1 to 14 and describes how much H+ is in a liquid. If there are more H+ than OH-, the pH is less than 7, and therefore the liquid is acidic. If there is less H+ than OH-, the pH is greater than 7, and the liquid is basic. If there are the same amount, the pH will be 7, and the liquid is neutral. A fun fact to note is that some common acids are things that we can eat and taste sour. Some common bases we run into every day are very slippery. So, for example, let's look at water. For now, the H+ will be the red M&Ms.
Can I put it down?
Yes, and the OH- will be the blue M&Ms. This means water is neutral and has a pH of 7. We add in our mystery yellow, whatever we are testing, and it will combine with the blue and only leave red. And this will be more acidic. Now, if it combines with the blue, there will be more OH- and it'll be a base. This is why we see red for an acid or blue for a base. Today we will be using lime juice, lemon juice, vinegar, baking soda, and detergent as our household liquids. We will then be using a cabbage indicator to help us determine whether the liquid is an acid or a base. We will also need cups, measuring cups, a pipette, and a stirring stick to help us measure the liquids. An indicator is something that changes the appearance when it is introduced to our acid or a base. Our indicator comes from the humble red cabbage. The indicator will turn pink if the liquid is an acid, or it will turn blue if there's a presence of a base. As all scientists do, we will begin our experiment by hypothesizing what we expect our results to be. Knowing that acids are sour and bases are slippery and bitter, which of our liquids do you hypothesize will be an acid? Which ones do you think will be an acid? The lemon juice, the soap, or the baking powder? Which one's sour?
Lemon juice.
Okay, so you hypothesize that the lemon juice will be an acid. All right. And what about for a base? Which one would be slippery? Would you say soap, lime juice, or baking powder?
Soap.
All right, so you're hypothesizing that soap will be a base. All right. When scientists perform an experiment, they call the steps they use their procedure. Our procedure starts with step 1, gathering our materials. The powders here need to be reconstituted in water. However, we cannot just mix a random amount of water to a random amount of powder. It needs to be exact. So, do you remember what color an acid is?
Acid is pink.
Oh, very good. It is pink. And do you remember what color a base is?
Blue.
Fantastic. So we're going to start reconstituting our liquid. So we're going to put the baking soda, baking powder in the water. I'm going to start on this side. So you go ahead and pour everything in there. Teaspoon of water. And it's really important as scientists to get down on eye level to make sure that you measure appropriately. All right.
Hot.
Lemon juice. I like to use warm liquids because it helps the powders to dissolve more quickly.
This is actually steaming.
All right. So we're using a ratio of 1/2 teaspoon to 1 teaspoon of water. So we use 1/2 teaspoon of each one of the powders. All right, so now we're going to go around and we're going to test each one. So let's start with baking powder. Okay. Can you put a little bit in there and let's see what color it is. All right. What color is that, William?
Blue.
Blue. And what is blue again?
Base.
Fantastic. Yes, it is a base. So baking powder is a base. Now let's go over here to vinegar. Let's see what vinegar, the result for vinegar will be.
No.
Okay, test it. You can have a hypothesis, but you still have to test your hypothesis.
Pink.
Pink. And what was pink again?
Acid.
Yes, very good. So let's look at soap with water.
Soap with water.
Soap with water. Let's put that in there. Oh, right. What color is that?
Oh, definitely blue.
All right. So what is that? Acid or a base?
Base.
Very good. And let's go over to lime juice. What have you hypothesized for lime juice?
My hypothesis for lime juice is, I don't know, maybe.
All right. So what color is that?
Pink.
Pink. And so that is a acid or a base?
Acid.
All right. And last but not least, lemon juice.
Wait, what about?
We'll do water at the end, yeah. Oh, you have nothing in there.
What?
Go back over here. Squeeze that up. Oh, so lemon juice, what color is that?
Okay, acids.
It's an acid. Because what color is it?
Pink.
Very good. And let's look at water. So water we talked about being a neutral solution and being about a 7. So let's put that in there. All right, so that's purple. It's more neutral. All right. So the most important steps for scientists do is to write down our observations. These are our results, and we can now record our results. The lemon juice, lime juice, and vinegar were acidic, and the detergent and the baking soda were basic. So here you see we have our pH indicator levels. So we have our acids that are pink and our bases that are blue. So we have our water, which is a 7, and the acids that we tested were the vinegar and the lemon juice, and lime juice is about the same, so it's about a 2 as well. For our bases, we had baking soda, which is about an 8, and the soap, which would fall around 11 because it is close to the ammonia, household bleach, and the lye. Thank you, HYPOTHEkit, for joining us for today's HYPOTHEkit, and we hope to see you again soon.